settled in? Thank you all today for being here. My name is Lori Aratani. I'm a transportation reporter here at the Washington Post, and I am joined today by industry experts to talk about a key variable in any conversation about the aviation industry. That's energy and fuel. With me on stage today is Bill Brown, Commercial Engines Marketing Manager at GE Aviation, Kristen Sliker, Vice President of Connected Aircraft at Honeywell Aerospace, and Michael McAdams, President of the Advanced Biofuels Association. Before we get started, be sure to tweet any questions you have for our panelists using the hashtag #TakingFlight, and we'll try to get to some of those later on in our conversation. Fuel is the second biggest operating expense after labor, and prices are rising again. And because of that, so are your baggage fees. But there's something different this time. The jets that are flying are more fuel efficient. Today's Dreamliner burns 3 times less fuel per hour than the 747. Bill, we're hoping you can talk to us a little bit about the technology that makes that possible and what that's going to mean for passengers and airlines.
Okay, yeah, thank you. First, I want to thank the Washington Post for the opportunity. Yeah, when we talk about technology innovation, everyone wants to talk about the future and what's coming next. And the first part of innovation is what's now, and you just mentioned it, those aircraft that are in service right now. And what's driving that is we have technology development, and really in 3 areas we kind of categorize it: architecture, aerodynamics, and materials. And why these engines are better is the architecture of the engine. They're larger fans, smaller cores. That's the fundamental efficiency of the engine. The aerodynamics are better, so we compress the air better now. And the big revolution really right now is materials. Following the space program and the military, it's called a revolution called Beyond Metals. The front end of the engines now are made of carbon fiber, 1,000-pound weight reduction, stronger. And the big development is ceramics in the turbine. So we're replacing metals in the turbine with ceramics. 1/3 the weight, twice the strength, more temperature capability. And you've already seen this in the military and in aerospace, but now it's coming into commercial aviation. The big trend, you can see it, is universities now used to graduate metallurgists, and now they graduate engineered material engineers. So the big difference now is really what we consider beyond metals, and that is a large part of the efficiency of these new engines.
So it means planes can fly further on less fuel?
Less gas, and it is. You're starting to see some ranges now where airplanes are flying 18, 20-hour flights. Whether that's the traveling public wants that or not, it is nice to not to have to connect sometimes on your way there. So it is. The combination of the architecture of the engine and the aerodynamics, but most importantly, the materials, because weight is the enemy of aviation. I mean, lifting weight is not efficient if you don't have to, and materials that are 2/3 weight reduction are revolutionary. We invest a lot to get 5 or 10% weight reductions, but ceramics gives us a 70% weight reduction. So those are huge developments. They take 20 or 30 years to perfect them, but they are now starting to come into engines. This generation, next generation will have more and more ceramics.
That's exciting. That's exciting. Well, I know fuel-efficient jets are part of the equation, but there are other elements that are going into making flying hopefully more efficient and more fun or less of a hassle. You've heard of smart homes, I'm sure you all have, but now we have something called connected aircraft. And Kristen, I'm hoping you can help us understand this idea of a connected aircraft and how it harnesses data to improve the flight experience and the bottom line.
Sure. So I think a lot of us have heard about the Internet of Things and the types of possibilities that creates. But with a connected aircraft, you're truly able to bring together the physical and digital world, so that the airplane, along with the data that comes off of that airplane, to understand where you can anticipate possibilities to do things different. So if you've ever been stuck in an airport with your children waiting for a maintenance delay, or heaven forbid with somebody else's children like crying in the next aisle, you know that you would rather have airlines have the ability to anticipate disruptions. And with some of the data analytics that can be done with the connected aircraft, we're actually able to anticipate with a 99.5% success rate 1 to 3 days before a flight when parts might fail, when you might have an unscheduled disruption. And so airlines are able now to use that data from their own operations, and then apply analytics to that data so that they can make those predictions and make flight just a lot nicer for all of us. So, and we talk about fuel efficiency. The same type of data analytics can be used to drive fuel efficiency as well. And so we talked a little bit about how weight is, it's one of the enemies of driving an efficient flight. Well, airlines wrestle today in an environment where, the cost of fuel is 20 to 40% of their operation. And one of the things that they're expected to do is to carry reserve fuel or contingency fuel for their flights. And today there is a lot of regulation that would say how much contingency fuel is required to ensure safety, but safety can still be ensured using less fuel through things like statistics and statistical fuel control. And the Honeywell Go Direct software that we work on at Honeywell actually helps airlines to better plan. And so you can sometimes take those reserves from a 10% level down to a 3% level, making flight more efficient and really helping to reduce this carbon dioxide output from a flight. So a lot of really exciting things.
How does, we've had a lot of weather issues. How does a connected aircraft work when it comes to weather?
Yeah, so it's helpful first to think about a connected aircraft a little bit like how your cell phone works. So first you connect the plane with satellite equipment or antennas that can allow you real-time communication. You have satellites that can provide that airtime to the jet, just like you get airtime services on your own cell phone. And then you have apps that are enabled based on doing that. Well, when it comes to weather and avoiding bad weather, for example, that real-time connectivity to the airplane allows for pilots to actually see developing weather, and it allows for them to get information real-time on how they can fly safer and more efficient routes. So there really is a possibility for your pilots to help you have a safer flight that has maybe less turbulence because you're dealing with less weather. And they're still able to do that while balancing, making sure they get there on time. Because at the end of the day, you drive efficiency by trying to get there on time.
Yeah, that's exactly. I think that's what everybody wants in their flight.
Yeah.
Well, I know another way that airlines are sort of tackling this issue of rising fuel costs is by using more biofuels. I've heard some dub the effort farm to fly. Michael, can you talk a little bit about what airlines are doing in this area and what it might mean both for their bottom line and also for the environment?
Sure. So I'd like to do three things today. I'd like to tell you where we are today. I'd like to tell you why we need these fuels and when they're coming and how they're coming. Okay, so for the first part, let me just tell you where we are. As a globe, we use 100 million barrels of oil a day. Okay? In the United States, we use 20 million barrels of oil a day. So we are 1/5 of the world's consumption. When you look at the yearly use of fuels in the United States, we use about 220 billion gallons. Of that, about 144 billion gallons is gasoline, 55 billion gallons is diesel or distillate, and 20 billion gallons is jet. So where are we in the biofuels world today in America? We're at about 20 million gallons a year, 20 million out of 220 billion, about 10%. Most of that is ethanol. You cannot fly an airplane on ethanol. You cannot fly an airplane on biodiesel because they have oxygen in them and they freeze at 32 degrees. That is not a good thing for an airplane. I represent more renewable diesel and almost all of the guys that make the jet fuel, UPM, Neste, Altair, that are making it through all these range of feedstocks. So we're in our infancy as an industry. Relative to the 20 billion gallons, we're maybe in the hundreds of thousands of gallons right now today. But we have flown every kind of airplane in the world. I got to go out with Secretary Mabus and watch him fly the F-18s off the deck of the USS Nimitz on jet fuel made out of chicken fat. I got to be on the first flight cross-country with Alaskan Airlines with jet fuel made by REG's facility down in Louisiana. So just to be brief, you see the size and scale. We have a world that is predicted to be 9.7 billion people by 2050. And with that, you're going to have increased energy use. So the only way we're going to be able to tackle climate change when transportation is about 35% of the GHG emissions in the world is if we make these fuels in partnership with our customers, the airline industries and their providers, together. So I'm really delighted to be here to talk about what we need to do to get to that next step.
Yeah. I know United recently unveiled a very ambitious plan to cut its emissions by 50%. It's also got a sizable investment, it sounds like, in a biofuel company out in
I think they have several investments.
Yeah, several investments. Talk a little bit about.
And so to knock away any myths, right, I represent Fulcrum, which is building a Fischer-Tropsch plant in Oregon. Pardon me, that's Red Rock. Fulcrum, which is building a municipal solid waste cellulosic plant in Nevada. And Ensign, who is just completing a 10 million gallon plant in Quebec, which is a pyrolysis oil that can be upgraded into jet fuel. So the technologies are moving. The people that I represent every part of the commercial chain. And what we want to try to do long term is build a sustainable economic model so these fuels can compete with the 100-year existing incumbent industry without endless subsidy. And so that's the challenge that we need to talk about in terms of what policy support that we need to move forward over the next 15 years.
Yeah, I know at Honeywell, we've actually been very engaged in what you can do with biofuels to power aviation, and our Honeywell Green Jet Fuel actually has been used by United and Qantas and others. It's a drop-in replacement, so chemically the properties are similar to Jet A or the same as Jet A, so there's no modification required to the aircraft itself in order to enable using those types of biofuels. And so now you're able to use more sustainable sources for your fuel. You're able to do that safely, and we're seeing flights now where carbon dioxide emissions are dropping by 60% through the supply chain as a result of being able to use these types of alternative fuels. So it's very exciting.
Yeah. And our participation in that, because that's one of the key things. It has to be intermixable and interchangeable. We don't want to have dual fuel sources, which is really a formula for not good things in aviation. So these fuels from the engine manufacturer, the engines will run on whatever they develop because one of the criteria of the fuels is that they have to be not just interchangeable, but intermixable, both fuels in the tank at the same time.
So we refer to those fuels as drop-in fuels, and they're absolutely identical to the fuels that come from a barrel of oil from a refinery. But we can make them out of wood, we can make them out of trash, we can make them out of sludge, we can make them out of sugar. There's a whole range of technologies that are coming to the fore. I've seen the chicken fat and I've seen the wood fly in F-16. And so these are really cool novel technologies, but we need to have consistency around the renewable fuel standard. And you all need to be concerned as consumers that we do the right thing for the world and the United States relative to climate change moving forward. Thank you.
Great. Well, it looks like we have some questions coming in from Twitter. We have one from George who says, as we introduce the new Internet of Things tools on planes and in airports, what factors inform how we should be securing these new tools and the data sets they collect from cyber intrusion?
Yeah, no, it's a really important question. And so a couple important things to understand is that there is an enormous amount of effort placed on ensuring that there is segregation in the way that data is accessed on an airplane. And at all times, a pilot has control as to whether or not their aircraft is going to retain connectivity or not, so that they have the ability to fly that plane safely. The cockpit is treated uniquely from the cabin, and so those things are on separate domains. So there are a lot of measures taken to ensure overall safety and security. And so I think what you'll see is that the technologies that are being brought to the market that drive connectivity, cyber is one of the foremost thoughts, at least that we look at it at Honeywell, is how do we make sure that passengers are safe? At the end of the day, you want a true home-like experience in the air. You want to be safe. You want to be able to have the option of connectivity, be able to text, be able to do your Christmas shopping from the plane if you want to. And so you need to be able to do that in an environment that you can trust and feel safe to fly in.
Yeah, I wanted to jump in on Kristen's topic there. She mentioned the cockpit and the cabin, and the engine manufacturers are concerned with the cabin digital. What it is, in the past, when you managed engines and what they were doing, it was a very physical interaction. The aircraft landed, you physically looked inside the engine if you thought there was something wrong. Now digital analytics has gone to where you can monitor the engine in flight and you can see what's happening, vibrations and temperatures. The new frontier we're entering now is almost the same as facial recognition. Our engines we're building now, we're monitoring like 800 critical characteristics of the engine while it's being manufactured. Dimensions, temperatures when it's manufactured. So now when we're monitoring an engine, when something happens, we can look at every other engine in the world and look for a similar footprint or fingerprint of that engine. We call it the digital twin. In the past, we just treated engines as an average performer. Now we have a fingerprint of every engine, so when something happens, we can start looking at every other engine and determine what the footprint of that is, and the analytics allows us to manage this, the reliability of these projects much better. That's where digital analytics is from the manufacturer's point of view of maintaining the reliability of these, this equipment.
That's interesting. Can you all talk a little bit about what is driving innovation? I know fuel prices are up and down. What other factors do you think are driving innovation?
Well, I'll jump in on that one because I've been in aviation a long time, and I've seen from the 80s, even the 70s, which was before my time, but it was an industry that was a new industry. And like most industries, there's an acceptance of new technology to be less than reliable. I mean, computer industry, televisions, phones, anything. At the beginning of an industry, the thrill of the technology draws some or allows some acceptance of its unreliability. The maturing of the aviation industry now, today, that acceptance of unreliability is gone. Airlines are not always run by technologists or pilots or engineers anymore. They're run by business people more often, and their acceptance of the lack of reliability of new technology is gone. So now these technologies have a much higher standard of performance than they used to, so there is no learning in service. You have to, engines going into service now have 5 to 15 times better reliability than they did 10, 15 years ago. So that's part of it. We're developing materials and hybrid electric technologies and all these things, but the bar of reliability is much higher than it ever was before, but that's the big difference today.
Yeah, I think, I mean, at the end of the day, airlines want you to select their airline. They want to be a pleasure for you to fly. And so between the desire to have passengers select you as an airline, along with the fact that airlines know that technology can help enable them to better integrate their operations. So what was historically kept as maintenance records over here, flight operations records over here, or how we manage the gate over here, those types of things can now be brought together with technology. So, you know, an example would be the GoDirect software that Honeywell produces. We do things for ground turn, where the combination of having a gate turn tool along with telematics on the airfield that allow you to see where all the ground equipment like refueling trucks or catering trucks are, it enables airlines to actually turn the airplanes, you know, 25% faster at least. And so when you're able to do that, you're able to recover faster, you're able to stay on schedule. Airlines really do. They want to make sure that it is a pleasure to fly, and they want to be able to do that in an environment where they do have to manage their cost structure.
Yeah. And I would say on that, the airlines have been significant in terms of helping drive my industry forward in terms of trying to bring new evolutionary technologies to the fore. I had a chance to work for BP for 15 years, and we were a global operator. These are all global operators. You operate, your license to operate is given to you by the people around the world where you fly into the airspace and the airports you land on. Same with drilling wells. And so the folks that I represent are true innovators, right? Who they're trying to bring these sustainable fuels under the renewable fuel standard. Most of them are required to do a 60% greenhouse gas reduction. It's the only climate change program in the country that has actual variables in it. But our challenge to our customers, as I was talking to you, is to deliver an economically competitive fuel that doesn't need an endless subsidy for 40 years. And the people I represent don't want to do that. We just need a hand up to get parity. And as we see crude move forward, that helps reduce some of the risk of the technology in terms of the return. So we're making real strides. We're building three plants right now that are cellulosic plants in the United States that will bring real gallons, all of which could make a jet fuel. So we're in our infancy, but we've got to have certainty, and we've got to have partnership with the airline industry moving forward to bring that reality into the future.
Oh, great. It sounds like an exciting time. There's just so much innovation going on in so many sectors, and I know that for folks that fly, often they like this idea of being able to have a flight that's on time, move quickly. I mean, I know that people think a lot about the time in the air, but as you mentioned, Kristen, it's this idea of the turnaround too that really makes a difference.
Yeah, and when you look at what's possible with innovation, right, when you start to look at connected technologies, you know, at Honeywell we look at how do you connect your entire enterprise? And so as a passenger, you can think about, you really want to have an experience from the time you even conceptualize taking a flight to the time that you return, whether that be through the transportation to and from the airport, the security process, the actual flight itself, the overall efficiency and how the environment's being treated through that whole process. And so when we look at connected technologies, we consider all of those critical types of connections that can be made to enable a really fantastic overall integrated experience. And so I know for myself as a passenger flying a lot, I'm really intrigued by how much aviation is going to be able to change to make it an easier process as a passenger and just be so much more efficient for everyone involved in the overall process.
It's true. It's all about communication, right? Even between people, but also between machines, right? It all makes things more.
Well, I'd like my hotel to know what my preferences are. We have software that does that. Yeah.
Yeah. And Kristen mentioned turn time. We have a new requirement from airlines. For 40 years, it's been reduced cost. You know, fuel, maintenance, all that.
Right.
Now it's asset utilization. They spend 50 to 150 million for a new airplane, and the revenue side of it is if you miss a flight is $30 to $150,000 in revenue. That is huge compared to the cost. So what it is now is saying, right now it's asset utilization. More flights per year for the same assets, and that more flights, and that's why the new equipment going into service is exceeding the utilization of mature, older equipment. So that's a testament, again, to the lack of acceptance of the unreliability. New products have to be high utilization assets from the moment they go into service. Our first aircraft in service at Turkish Airways last year flew 300 flights in the first 30 days. 10 flights a day per day for 30 days. The first aircraft off the line, an Airbus A320neo. That was a testament to the reliability and the utilization of an asset right off the line. That was probably not possible 30 years ago, but that's where we are today.
That's pretty amazing. How does that compare to what it would have been? I don't know. I guess that's hard. 30 years ago.
Well, 30 years ago, you would have babied an aircraft into service. You would have put it on certain flights where you had lots of mechanics. You would have you would have been checking it every night to make sure. But now the airlines say, listen, I bought you it's like when you buy a car, you don't hesitate to go on an 800-mile trip the next day.
Right.
They don't hesitate to put that aircraft into service, and that's exactly what they do. The expectations are much higher from our customers.
Yeah.
Yeah. Airlines and ground handlers, or those that carry freight, I mean, they quantify the amount of time missed using their airplane down to the minute, right? They know exactly how much it costs down to the minute. And so technology that allows for better optimization of the required inventory so that if something does happen, I actually know what to do about that. And then being able to predict failures so that I don't have to ever experience downtime. It's critically important. You've made that purchase of an asset because you want to be able to use it. And at the end of the day, it benefits all of us when they can keep doing their jobs.
And if you look at the statistics, the airline industry's, in the next 15 years planning to double, right?
Yeah.
So they used $133 billion worth of fuel this year. So we're going to need to have those sustainable fuels as we double the air travel, because it's 2% of all the global climate change. And the gasoline is different than the jet fuel because it's from the distillate column. So when you look at the greenhouse gas reductions, about 30% of it's from the distillate column, which requires a different type of process to make that fuel. And I'll tell you, having spoken to the Congress several times on this, they get hung up around ethanol and they forget that this is a distinctly different molecule. So we've got to have this all balanced, and we can't look at it through one lens. We've got to look at it holistically.
So I guess the hope is that you'll have a more efficient flight. I guess for the passengers, what do you think the result is for passengers? Everyone's always you want a pleasant flight, but you're also very price conscious. So do you think this helps passengers looking to buy tickets?
To me, I think it benefits passengers in both ways, ultimately over time. Both my flight can be more of a home-like experience. It can be more cost-effective because we're able to control the cost of fuel. I know I'm doing better things for the environment if I'm using the right materials. And I think the overall process around travel you're going to see a lot of exciting innovations that make it nicer to be a traveler.
Yeah.
Thank you very much.
Great. Well, that concludes our segment. Thank you, Bill, Kristen, and Michael for being here. Now I think we'll be moving to the next portion of our program.
Okay.
Thank you. Oops. Thank you so much.